Hi everyone, this lesson is part 2 of the second semester Algebra 2 Trig Advanced review for the final. We are going to be covering the questions that are in the packet, so we certainly have a lot to cover, so let's get started. First question started out with true or false, whether or not sine of 135 is equal to cosine of 45 degrees. So sine of 135 degrees is over here. 135 degrees gives us a 45 degree reference, sine being 1 square root of 2 because it's 45 degree reference, sine being opposite over hypotenuse, which becomes root 2 over 2. Cosine of 45 degrees, and cosine is in the first quadrant at 45 degrees, so that's 1 square root of 2. So cosine being adjacent over hypotenuse, 1 over root 2, again, which translates to root 2 over 2. So these two are correct. An angle whose measure is 87 degrees. So an 87 degree angle is in the first quadrant, right there at 87 degrees. Coterminal means it ends in the same place. So does this end in the same place as a measure of 93 degrees? 93 degrees is going to be up to here, and no, those don't end in the same place. The next question says, an angle whose measure is 19 degrees, so that's going to be right about here, from here to this value to that is 19 degrees, has the same sign as an angle whose measure is 341 degrees. So in this quadrant right here, we have all students take calculus. So in quadrant 1, we have the same sign as an angle is 341. So 341 degrees is all the way around to here, okay? And these values here are definitely not the same. In the first quadrant, sine is positive, but in the second quadrant, sine is negative. So therefore, or excuse me, in the fourth quadrant, sine is negative. So this would not be true. These would have different signs, like one's positive, one's negative. The angle of elevation to the top of a flagpole, okay, so let's say this is my flagpole here, and there's my flag, apropos because it is Memorial Day weekend. An angle of elevation that of a top of a flagpole that's 15 feet away, and so that's always going to be ground distance, is 37 degrees, and so that's 37. So angle of elevation is going up. The flagpole must be approximately 11.3, so height, so that they're saying that's 11.3. So what you're going to do is this is opposite and adjacent, this being a right angle because a flagpole is going to be perpendicular with the ground. This is what you're going to be doing. You're going to say, is tangent of 37 degrees equal to 11.3 divided by 15, opposite over adjacent. So in this case, the flagpole, tangent of 37 degrees, I end up getting that this is I end up getting that that is true, and so use your calculator to figure that out. The period of this right here is 4 pi, true or false. Now remember that for a period for tangent and cotangent, or for tangent and cotangent, the period is normally pi over the frequency. And the period, if my frequency is 1/2, that's the same thing as saying pi over 1 over 2. So that's pi divided by 1/2, which is the same thing as saying pi times 2 over 1. So pi times 2 over 1 is 2 pi. And so the question is this period for this equation 4 pi? No, in fact, it's 2 pi. The next question says the terminal, again, that's the ending place, of the terminal ray of an angle, the end angle, in standard position passes through negative 2, 3, so over 2, up 3, so negative 2, 3. So they want this right here. So this arc, because that's standard, of secant of that. Now secant is the reciprocal of cosine. So if cosine of an angle is equal to adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. So what we need to do is we need to find out what our values are here. We know that's negative 2. We know that's positive 3. So that means that my hypotenuse, if I were to use Pythagorean theorem, is going to be 9 plus 4 is equal to my hypotenuse squared. So my hypotenuse is equal to the square root of 13. So there's square root of 13. So secant of that is going to be hypotenuse, which is root 13, over adjacent, which is negative 2. This one says the point negative 2, 7, so there's 7. So this point right here is on the terminal side of an angle again. So negative 2, 7. And then again, come straight down. We know that's negative 2. We know that's 7. We need to find cosecant of theta. So remember, cosecant is the reciprocal of sine. So if sine of an angle is equal to opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. And there, your theta being right there. So we do need to find the hypotenuse again. So we know that a squared plus b squared is equal to c squared, c being my hypotenuse. 49 plus 4, which is 53, is equal to x squared. So x is equal to the square root of 53. So that's going to be right here. This one is going to be hypotenuse over opposite. So this one for cosecant is going to be root 53 over 7. And that's cosecant of theta. The next question says, in which quadrant does the terminal ray of negative 235 lie? So this is negative 90, negative 180, and here's negative 270. So it's not quite there. It's around here. So what quadrant is that? That's quadrant. So this is quadrant 1. This is quadrant 2, quadrant 3, and this is quadrant 4. So it lies in quadrant 2. This question says, change each of the following to radian measure. So we have a formula that we use to convert from radians to degrees and degrees back to radians. And that is theta equals 180 over pi times x. If we are using degrees, that goes in this side here. So that would be 25 degrees equals 180 degrees over pi times x. And so to get x by itself, you're going to get 25 times, you're going to multiply by the reciprocal, which is pi over 180 degrees. So for question number 9, you end up 25 over 180. That becomes, for this problem, x equals 5 pi over 36. So that reduces to that. For this, because you just divide by 5. For this one, 270 degrees, I could also plug in 270 here, but at the same time, I can say, well, I can count. If I'm trying to go into radians, right, this is pi over 2, pi. So this is a half a pi, 1 pi, 1.5 pi, 2 pi. So at 270 degrees, which is right here, that's at 1.5 pi, which is 3 pi over 2. I also could use the formula and go 270 equals 180 over pi times x and then multiply by the reciprocal. For this question, it says change these to degrees. So I just like using my graph. However, I do believe that using the formula is advantageous also. But for this first one, I'm just going to move this 2/3. If from here to here is pi, then 2/3 pi is going to be here. That's a third. This is 1/3, 2/3. So really, it's from here to here. So 1/3, 2/3. That's where I'm at. I'm in second quadrant. 3 divides into 180 60 times. 60 times the 2 is 120 degrees. So therefore, we're at 120 degrees. You also could use the formula theta equals 180 over pi times x. Because it's in radians, that goes in the x value, which is 2 pi over 3. Pi's cancel. 3 goes into 180 60 times. 60 times 2 is 120. We'll use the formula again. Theta equals 180 over pi times x. This is my x because it's a radian, and I'm trying to make it into degrees, which is theta. So you're going to go 5 pi over 12. Again, the pi's are going to cancel. And ask yourself, 12 goes into 180 times. And So what I'm going to do is, what do I want to do? I want to go, this is 6 times 2. 6 divides into this 30 times. 2 divides into 30 15 times. 15 times 5 is 75 degrees. The next question says, given this, sine of this equals 0.8632. Find cosecant. Now keep in mind, cosecant is a reciprocal of sine. So if sine of 2.1 is this, then the reciprocal, which is cosecant of 2.1, is equal to 1 over 0.8632. Okay, that's your answer without a calculator. I guess with the calculator, I mean, you could divide that out if you were allowed a calculator, and you would get, I think, that value. But most times you're not using a calculator. The next one says, find the positive and negative angle with pi over 7. So pi over 7 is here, first quadrant, because this is, remember, this is 1 pi. So this is a 1/7 pi. So if I want to get back to this, I'm going to go all the way around and then come back. So I'm going to go 2 pi plus pi over 7. And I would, of course, get a common denominator, which would be 7. So I have 14 plus 1. So that's going to be 15 pi over 7. And then, so that's my positive value. And my negative value would just be pi over 7 minus 2 pi, because then what that's doing is it's making me go back around like that in a negative value. And again, I get a common denominator times 7 over 7. So we have 1 minus 14, and that becomes negative 13 pi over 7. Supplement and complement. Supplementary angles add up to be 180 or 2 pi. Complementary angles add up to be 90 degrees or pi over 2. So if I start off with pi over 6, keep in mind pi over 6 is 30 degrees. And so I'm trying to find the complement to that. So that would be from here to here. The complement would be pi over 2 minus pi over 6. And so that would just multiply by 3 over 3 to get the 6. So this is going to be 2 pi over 6, which is pi over 3. So that's my complement. And my supplement is going to be 180, or pi, minus this. So pi minus, let's see here, pi minus pi over 6. I'm going to get a common denominator, and so I just get 5 pi over 6. Okay, that's my supplement. This question says the terminal side of the angle passes through the point -3, 4. Okay, so here we are. And this is -3 here, 4 here, 3, 4. That makes this a 5 because it's a triplet, one of our triplets. Find each of the following. So this is theta here. So sine of theta is going to be opposite over hypotenuse. So that's going to be 4 over 5. Tangent is opposite over adjacent, so 4 over -3. Cosine is adjacent over hypotenuse, and secant is secant being the reciprocal of cosine. Remember, cosine also being negative in that case, so it's going to be -3 over 5, so 5 over -3. So you could just write -5 over 3. For this one, it says if theta is an acute angle and cosine of theta. Now remember, acute angles are always in the first quadrant because they're less than 90. So this being cosine, cosine being adjacent over hypotenuse. And so this is another triplet. This is a 5, 12, 13. Find cosecant. Cosecant's the reciprocal of sine. So sine... So if sine of theta is equal to opposite over hypotenuse, then cosecant is hypotenuse over opposite. So that's going to be hypotenuse over opposite, which is 13 over 12. This says, from a point 5 meters above level ground, an observer measures the angle of depression. So keep in mind, what we're looking at is a right triangle. okay? You're looking at an observer. Here's your observer, okay? And they're 5 meters above ground. So there's your 5. It says that the angle of depression, now what you do need to remember is that the angle of depression is always based on the horizontal. And therefore, this is not the angle of depression. The angle of depression is this arc right here. It's that degree in there. And that is 71 degrees, which then makes this 71 degrees because those are alternate interior angles. Approximate the distance from the object to the point on the ground directly beneath the observer. So what they're looking for is the place from here to here, which is x. So if you have a calculator, you would solve this. But if you don't have a calculator, you're going to simply write tangent, because that's opposite over adjacent. So tangent of 71 is equal to 5 over x. And that would be my answer. I would solve for x, of course. I'd get x times tangent of 71 is equal to 5. So x equals 5 divided by tangent of 71 degrees. Now, if I don't have a calculator, that's my answer. If I do have a calculator, I'm going to divide 5 divided by tangent of 71, and I'm going to get approximately 1.72 meters. All right. The next question says the angle of elevation of a kite is 65 degrees. So let's say here's my kite up here, and this is my string, and this is the height of the kite, and there we are. So the angle of elevation, that's the angle that you're looking up, is 65 degrees, okay? It says 490 feet of string, so that's my string, because if this is my kite right here, okay? I guess I could use a different color. If that's my kite, this is my string, all right? And it says, assuming that the string is taut, how high is the kite? So what you're finding is opposite over hypotenuse, which is sine. So you're going to go sine of 65 degrees is equal to x over 490. If you have a calculator or not, you're going to start off like this and go x times 1 is x is equal to 490 times sine of 65 degrees. One note is if you are using a calculator, you need to make sure your calculator is in degrees and not radians. Multiplying these, I get 444 feet, and so that would be my answer if I had a calculator. If I did not have a calculator, this would be my answer right here. I would just leave it in that form. The next question says, find the exact value. So for this right here, sine, remember sine is the same, so sine of 120 degrees. So for this value here, sine 120 degrees is over here. 120 has a 60 degree reference, this being root 3, here's 2, here's negative 1. So sine of 120 degrees is opposite over hypotenuse, so that's going to be root 3 over 2. Tangent of negative 45 degrees, that's dropping down 45 degrees. So tangent 1 square root of 2. But remember, this is negative. Tangent is opposite over adjacent, so that's negative 1. Cosine of 3 pi. So let's see here. Let's count. This is 1 pi, 2 pi, and then 3 pi. Where are you? At 3 pi, you're at negative 1, 0. And remember, it always goes cosine first. So cosine, then sine. So negative 1 is cosine. So this would be negative 1. Negative 1. Secant of 5 pi over 4. So first of all, 5 pi over 4, this is 1 and 1/4 pi, okay? So this is here, from here to here is 1 and 1/4. Now in my mind, I'm thinking 1/4, right? That's a 45 degree angle, which is 1 square root of 2. And 45, so we know that so far, there's theta. Secant's the reciprocal of cosine. And if cosine is adjacent over hypotenuse, then this is going to be hypotenuse over adjacent, which is just going to equal negative square root of 2. This one right here says, given sine is this, cosine is this, and tangent is this. They want you to find all, or I'm not sure what they want you to find. Let me move this over. Find something. 6 trig functions. Okay, so we need to find the 6 trig functions of 61.6 degrees. So that's just going to be, to start off, we know that if sine of 28.4 is equal to cosine of 61.6, we know that cosine of we know that cosine of 28.4 is equal to sine of 61.6. We also know that tangent of 28.4 is equal to cotangent of 61.6. So you can get an idea right off the bat. We can work this out. So far we know that sine of 61.6 is equal to cosine of 28.4. So therefore, sine of 61.6 is approximately 0.8796. And then we know that cosine of 61.6 is equal to sine of 28.4, which is equal to approximately 0.4756. And then tangent of 61.6 we know is equal to cotangent of 28.4, and that's going to equal approximately 1 over tangent of 28.4, which is about 1 over 0.5407. So there's like, and then of course you want to do the cosecant, secant, and cotangent of these, but you get the idea. If you write down what you know first, and then everything else you just can manipulate. And if you don't know something, if it's an inverse, you can always divide that number by whatever its approximation is. The next question says, given that sine is -4 over root 41, and it's in quadrant 4, so let's figure out what this is. Quadrant 4 being all the way over here. Okay, so here we are in this quadrant down here, and that we know that sine of theta is opposite over hypotenuse. So that's -4 over the square root of 41. Okay, and so what we need to do here is we need to first find, because we have to find the other trig functions, what we need to do is find this length right here. And we're going to find that length using Pythagorean theorem. So x squared plus -4 squared is equal to the square root of 41 squared. So we have x squared is equal to 41 minus 16. And for this problem, let's see here. Let's see, 20. This problem, this is going to be 41 minus 16, carry 41 minus 16, that's 5, 3, 25. So therefore, this length right here is the square root of 25, and the square root of 25 is 5. Okay, so what we're going to do here is we're going to find, we know sine is that, so we're going to find cosine, tangent, cotangent, cosecant, and secant. So cosine is going to be adjacent over hypotenuse, so 5 over the square root of 41, or 5 root 41 over 41. Tangent is opposite over adjacent, so -4 over 5. Cotangent is the reciprocal of tangent, so that'll be -5 over 4. Cosecant is the reciprocal of sine, so sine is going to be root 41 over -4. And the reciprocal of, let me close that, and the reciprocal of cosine is going to be root 41 over 5. Okay, so for problem number 21, we are trying to find two equations for each of these graphs. So there's a couple of these graphs that we're going to find equations for. So the first thing you need to know is that this right here, going from, this looks to me like a sine wave that's going to go like this. Sine waves halfway in between the highest point and the lowest point is going to be my sinusoid axis. Okay, I like to do my VAF, V-A-F-H-P. My V is my vertical shift, and this looks like I'm shifting down 1. My amplitude is the distance from my sinusoidal axis to the highest point or to the lowest point, and it's always a positive value. So this looks like 1, 2, positive 2. My frequency is, I'm going to get to that in a minute. The frequency is basically how many times you're going to see that graph in a 2 pi period. My horizontal shift looks like there is no horizontal shift because it does start at 0 if it is a sine wave. If I were to start it as a cosine wave, because remember cosine starts high and ends high, then I would have a shift of pi. My period though, so let's look at this. From the top, if you're thinking about a cosine wave, cosine starts at 0, goes up, goes down, ends at 0. That's a 2 pi period. So that's one full cycle. So what it looks like here is if I were to start down here, goes down, comes back up, and then it ends, same level. This from here to here is 2 pi, from here to here is 2 pi. That means my period is a total of 4 pi. Horizontal shift for this value is none. To find my frequency, I'm going to use my formula. Period is equal to 2 pi, because that's a regular 2 pi period, divided by my frequency. Because my period for this graph is 4 pi, that's going to go right here. So we're going to go 4 pi is equal to 2 pi over the frequency. I'm going to cross multiply. I get 4 pi times my frequency equals 2 pi. And I'm going to divide by 4 pi on both sides. And then I'm going to get my frequency is equal to pi's cancel, 1/2. So that means that my frequency is 1/2. My equation for my graph is going to be y equals my vertical shift plus my amplitude times sine or cosine. So sine times my frequency, x minus my horizontal shift. So for this graph, y equals my vertical shift, which is -1, plus my amplitude, which is 2, sine frequency 1/2, times x minus my horizontal shift, which I don't have one. To make this a cosine wave graph, I could start high up here, and then, cosine does this and ends high. But to start that off here, I would be shifting horizontally pi. So everything exactly the same, so y equals -1 plus 2, except for this word is different. Now it's a cosine wave, 1/2, and then my shift, x minus pi. All right? This graph is going to be either a secant or cosecant graph. Also, do your VAF, V-A-F-H-P, because you act like this is a sine or cosine wave until you get to the point where you switch it out. So basically right here looks like halfway between my high and low. So it looks like for me, for this graph, that my this is my new sinusoidal wave. So x, that's my new axis. So my vertical shift is up 2 or a positive 2. My amplitude from here to here. So my amplitude from here to here is, that's 1. So that's 1. My frequency, you hold on to that thought for a second. Let's see, let's put that back here. My horizontal shift, if my graph, and think about it like this, starts high. Remember, it's got to hit all these points. So then halfway in between, you're going to go through here. So it looks like it's going to go like this. Okay, so what this looks like to me is a cosine wave because cosine starts high. So the reciprocal of cosine is secant. So we're going to make our first graph a secant wave. Okay, a secant wave. In this case, my frequency, hold that thought for a minute. Horizontal shift is none because cosine starts high. The period goes from, if you look down here, this is pi over 2. So this is pi. So in this case, my period is pi. So if my period is pi, periods are equal to 2 pi over my frequency. So pi is equal to 2 pi over my frequency. Cross multiply, I get pi times my frequency equals 2 pi, divide. Frequency equals 2 pi divided by pi. So my frequency is 2. So then, let's see, what else do we have here? Everything's done. So we have y equals my vertical shift, which is 2, plus 1 is my amplitude. That always goes in front. Secant, frequency is 2, and I don't have a horizontal shift, so it's just x. However, if I were to make this a cosecant wave, that means I'm shifting it to sine, and that's going to go down to here, right here. And I'm going to start. Also, this will go down first, unless I shift it to the left. This will go down first. So if I were to graph this, it's going to be y equals still 2, but this will be minus cosecant of 2 times the quantity x minus pi over 4. Okay. Consider the function this and find all this information. So what we know, though, is that before you can find a horizontal shift, which is going to be somewhere in here, you cannot have anything in front of this x. So what you have is y equals negative 3 sine 2 times the quantity x minus pi over 2. Okay, so what we have is no vertical shift. We have an amplitude of 3, a frequency of 2, and a shift horizontally to the right, pi over 2. So my amplitude is 3. My period is equal to 2 pi over my frequency, and my frequency is 2, so therefore 2 pi divided by 2 is just pi. So my period's pi. Horizontal shift, right, pi over 2, and sketching the graph. Sine starts at 0, goes up, comes down, and ends at 0. This is my parent function. So what's happened is I have an amplitude of 3 negative. That means that instead of it going up first, it's actually going to go down. And it's going to go down 1, 2, 3 here. Still going to go through here. 1, 2, 3 here. And then end here. So that means it's going to go like this. All right. Because it has a period of pi instead of 2 pi, what that tells me is that my graph is all going to happen within pi. So all it's going to go down, come back up, and then end here. Okay. It looks like I have a phase shift of right pi over 2. So that means that my graph is actually going to shift to the right, pi over 2, and there's my final graph. The next question says, consider this function, y equals secant. Now remember, secant is the reciprocal of cosine. We also know this is my vertical shift. What's in front of the x is my frequency. My amplitude is 1. My period is 2 pi. My period is equal to 2 pi over my frequency, which is 1 over 2. Excuse me. And then, so that's 2 pi divided by 1/2, or 2 pi times 2 over 1. So that means my period is 4 pi. So, therefore, so the way you graph a secant wave is you pretend that it's a cosine graph until the very end. So a cosine graph starts high and ends high. Halfway in between it has a low point. So this is my parent graph of my cosine function. Okay, so we know that our amplitude is 1, so that's good. Dropping it down -2. So that means that I have a new axis at -2 right here. Okay, and so that's my new sinusoidal axis. So that means then it starts here, drops down, comes back up. Okay, so it does all this stuff right here. Same thing. All right, because my period is now 4 pi, that means it's still going to start at 0. Let me put this in green. It's still going to start at 0, but it's actually going to end at 4 pi. And as you notice on the red graph, halfway in between is my low point. So halfway in between here and here is going to be my low point. And then halfway in between my low point and my high point, I cross 0. So halfway in between here, I'm crossing 0, and I'm crossing 0. So my new graph is going to do this. And that's my final wave. This one's a tangent graph. And remember, tangents periods are pi. So the period is equal to pi over the frequency, that being my frequency. So my period is pi over 2. So for this to start and stop, it's going to be pi over 2, a total of pi over 2. So that means that if my period is pi over 2, that's the whole graph. So that means it's going to be pi over 4 left and right. So what a regular tangent graph does this. Because a regular tangent graph has a period of pi. It's going to be pi over 2, pi over 2. However, this graph has a period of pi over 2. So that means that my new graph has asymptotes here and here and goes like this, up that way and then like that. The only difference is that I have a phase shift of left pi over 4. So that means that this graph right here is shifting to the left, pi over 4. And so that's my new wave. My new final graph is this one right here. So for this problem, you are at a carnival riding a Ferris wheel. The Ferris wheel is 50 feet in diameter. So let's say that we have a Ferris wheel, and our Ferris wheel is going to be 50 feet in diameter. So that means it's 25 feet up here, 25 feet down here. Okay, when the ride starts at t equals 0, so that means here's 0 at t equals 0. The time you're starting at sitting at the very bottom of the car, the Ferris wheel makes 3 complete revolutions, 3 revolutions every minute. So every 60 seconds. So if I divide by 3, I'm going to get 1 revolution, which is my period, every 20 seconds. So this is my new period, is 20 seconds. Let's see, the center of the wheel is 30 feet above the ground. So that means that we already know this is 25 feet. So that means that we have a distance of 5 feet down here. So that means that so 5 feet down here, that's where it's going to start 5, and it's going to go up 5, 50, 55, up to 55, and then come back down. And this is going to be at 20 seconds. So halfway is going to be at 10 seconds. We know that's 5, and then if I were to add my whole diameter, it's going to be 55 up here. So to find the center of the wheel, it says the center of the wheel is 30 feet up, so 30 is this length here. So that means from here, 55 minus 30, that gives me an amplitude of 25. Okay, so I'm making my VAF graph. So V-A-F-H-P. My vertical shift is 30. My amplitude from here to here is 25. I'm holding off on my frequency for just a minute. I have no horizontal shift if I make this a negative sine wave. And my period is 20 seconds. So what you do is for period, the period is equal to sine waves 2 pi over 20. 2 pi over my frequency. That's what I'm trying to find. 2 pi over my frequency. And I know my period is 20 seconds, so this becomes 20. So 20 times f is equal to 2 pi. So that means my frequency is equal to 2 pi over 20, which is pi over 10. So that means that my equation is going to be, that's pi over 10 here. Okay, so if I make this a negative sine wave, it's going to be y equals vertical shift 30 minus, because it's a negative sine wave, amplitude is 25, sine, frequency is pi over 10, times the quantity, horizontal shift, so x minus nothing, which is just x. If I wanted to make this a positive sine wave, then I would go to this value here, which is in between here and here. So y equals 30 plus 25 sine pi over 10 times x minus 5 seconds. And if I wanted to make this a cosine wave, I would shift it all the way over to 10, and it would be y equals 30 plus 25 cosine pi over 10 times x minus 10. The next question is simplifying this expression. So when simplifying this expression, I'm going to simplify a little bit first, because I know my Pythagorean triplets here, my Pythagorean identities, that sine squared plus cosine squared is actually 1. So what I really have is cosecant of theta over 1 plus secant of theta minus 1. And then 1 minus 1 is going to go away, and I'm going to have cosecant of theta over secant of theta, and cosecant of theta is 1 over sine of theta, divided by secant is 1 over cosine of theta, and that's actually 1 over sine divided by 1 over cosine. Now division is the same as multiplication, reciprocal, so that's going to be cosine of theta over 1, which becomes cosine over sine is just cotangent of theta. Okay, and that's what that simplifies to. More simplifying the expressions, we know that cotangent, so Pythagorean identities, I can change cotangent to cosecant squared of theta minus 1 over this here, which is just cosecant theta minus 1. This right here is a difference of 2 squares, and that's just going to be cosecant of theta plus 1 times cosecant of theta minus 1 all over cosecant of theta minus 1. And this quantity here is going to cancel with itself, leaving me just with cosecant of theta plus 1. Okay? The next one is this, and I guess I'm going to just start off by distributing. So I have cosine of theta times, or x, excuse me, cosine of x, secant of x, minus cosine squared of x. Now, I'm going to see what happens with this. This becomes cosine of x times secant being the reciprocal of cosine, so 1 over cosine of x, minus cosine squared of x. These are going to cancel and make 1. So I have 1 minus cosine squared of x, and 1 minus cosine squared of x is just sine squared of x. And so that just simplifies to be that. The next question, this is the difference of 2 squares. I don't know if you realize that right here with the minus sign with both the squares here. So this is actually cosine squared of x plus sine squared of x times cosine squared of x minus sine squared of x. And that equals this right here. I know that cosine squared of x plus sine squared of x is 1. And 1 times cosine squared of x minus sine squared of x is just equal to itself, cosine squared of x minus sine squared of x. And then you would just bring this term down here to the bottom, cosine squared of x minus sine squared of x, and that's just a proof. So these two problems are using a sum or difference identity to find the exact value. So for this one, sine of 165 degrees, that's the same thing as saying sine of 45 degrees plus 120. Okay, and of course there's different ways you could do this, but this is the way I'm going to do it. Expanding sine is sine of 45, cosine of 120, sine is the same, plus sine of 120, cosine of 45. So sine of 45 is root 2 over 2. Cosine of 120 degrees is over here. That's a 60-degree reference. This is 1, and that's 2. So cosine being adjacent over hypotenuse, that's negative 1 over 2. Plus sine of 120 is opposite over hypotenuse, so that's going to be root 3 over 2 times cosine of 45, which is root 2 over 2. So this becomes negative root 2 over 4 plus root 6 over 4, which you can simplify only to root 6 plus, negative root 2 plus root 6 all over 4. And just to check, if you were to use your calculator on the top here, you would get approximately 0.2588. And if you were to use your calculator on this final answer right here, because this is an actual proof, anyways, an identity, you're going to get the same value, 2588, and that should be the same. This one is cosine of negative pi over 12. So thinking of what adds up to be 12 are 4 and 3. So this is actually the same thing as saying cosine of pi over 3 minus pi over 4. Now remember, expanding cosine, it goes cosine, cosine, and then sine, sine. So this is going to be cosine pi over 3, cosine pi over 4, and this is a minus, so this is now going to be a plus. Where sine had the same signs, plus and plus, cosine doesn't. And so this will be sine of pi over 3, and then sine of pi over 4. So cosine of pi over 3, so if you think of pi over 3, that's in the first quadrant. Pi over 3, 3 goes into 180 60 times. So root 3 here, 2, 1. Cosine is going to be 1/2. So we have 1/2 times root 2 over 2 plus sine of pi over 3 is root 3 over 2 times root 2 over 2. And for this problem, you're going to get root 2 over 4 plus root 6 over 4. And that just becomes root 2 plus root 6 all over 4. For the next problem, it says find cosine of 67.5 degrees. And 67.5 is basically double that, because we're using a half angle formula, so you have to double it. So that's cosine of 135 degrees over 2. So if you remember the cosine formula, it's going to be plus or minus. In this case, it'll be plus because it's a positive. 1 plus cosine of 135 degrees all over 2. So cosine of 135, if you think of that, 135 is over here, and it's a 45-degree reference. So we know it's root 2 over 2, but because it's in the second quadrant, cosine is negative. So what that's going to be is the square root of 1 plus this value, which is going to be negative root 2 over 2 all over 2. And this is going to simplify to be, I'm going to make this over 2, right? And so I'm going to get the square root of 2 minus the square root of 2 all over 2 divided by 2 over 1. And this, again, is all under the root. Well, dividing is the same as multiplying by the reciprocal. So that's as if right here, this is gone, and you're going 1 over 2. And so realistically, what we have is 2 minus the square root of 2. That's this right here, all over 4. Now, when I square root that, top and bottom, I get the square root of 2 minus the square root of 2, all divided by 2. And this value, if I were to check my answer, I'm going to get approximately 0.3827. And if I were to do that up here, I would get approximately 3827 also. This problem is sine of pi over 12. And again, I feel like I just did something very similar to this. This is sine of pi over 3 minus pi over 4. So that's 60 degrees minus 45. And so when I'm simplifying that, I'm going to get sine of pi over 3 cosine of pi over 4. Sine has the same, so minus. Sine of pi over 4 times cosine of pi over 3. So sine of pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4, root 2 over 2. And cosine of pi over 3, 60 degrees, is 1/2. So I'm going to get the square root of, I'm going to get the square root of 6 minus the square root of 2 all over 4. And you can approximate these, and you could check by just using your calculator and finding out what's sine of pi over 12, and that should equal the exact same value. This one says just express as a trig function. It goes sine, cosine, minus. So we remember that's going to be a sine of something minus, because sine has the same. And so this is just 55 degrees minus 10 degrees. And 55 minus 10 is the same thing as sine of 45 degrees. And sine of 45 degrees is equal to root 2 over 2. So this concludes part 2 of the Algebra 2 Trig Advanced second semester final exam review. So I hope this has helped so far, and look forward to seeing you for part 3. All right, thanks for watching.